ఓయ్ ఇది నెమ్మదిగా మాట్లాడుకోండి. Okay, good evening students. Today we are going to discuss about the topic tangents and secants to circles. First of all, we have to understand what is a circle. Suppose if you consider any fixed point, the set of all the points which are at the same distance from a plane forms a circle. Okay, it is the set of all the points which are at the same distance. The distance is a fixed. This fixed distance is called radius and this fixed point is called center of circle. This fixed point is called center of circle and this fixed distance is radius. So with given point as center and given distance as radius, we can draw one circle. Now suppose we are considering a circle and a line in a plane. What are the possibilities? Now you can see that the line may not cut the circle, or the line may intersect the circle at 2 points, or the line may touch the circle at only 1 point. Okay, here these are the three possibilities. Of course, here this is the center of the circle, and here you can see it touches at only 1 point, whereas here it touches at 2 points. Okay, now you can see that this line is called a non-intersecting line. And the line which cuts the circle at 2 points is called secant. And the line which touches a circle at only 1 point or exactly at 1 point is called a tangent. Okay, the point where it touches is called point of contact. So we can see that a line touches a circle at 1 point or 2 points, or it may not intersect. If the line is intersecting the circle at 2 points, it is called secant. If it touches at only 1 point, it is called a tangent. Now further, if we observe, in general, what are the terms that are associated with a circle and what are the things that we should know? Suppose if we consider a circle, this is the center of the circle. Now already we know that this fixed distance is called radius, and if you extend it further to the other side, it is diameter. Okay, this is diameter, and actually we know that a line cuts a circle at 2 points. This line is called secant. Whereas if we are considering only this line segment, means if we are talking about a line segment by joining any 2 points on the circle, then that is called chord. Chord means line segment joining any 2 points on the circle. Okay, if it is a line, so if you name it like some PQ, line PQ is secant and line segment PQ is chord. Chord is line segment and secant is a line. This is what we have to understand. Okay, and of course we know that tangent means which touches the circle at exactly 1 point. It touches at only 1 point. And this line is called tangent and the point where it touches is called point of contact. Now further we know that this is diameter, AB is diameter, and if you join O to any point on the circle, this is called radius. Now okay, this is OR. We can see that OA is equal to OB is equal to OR. This is radius. Means every point on the circle will be at the same distance. From this you can say further that diameter is 2 times of radius. And also we can say that diameter is the longest chord. Okay, how do we know? Let us see. Suppose we are considering a circle. In this circle, you keep on drawing line segments. These are all chords. Now there will be one point where it passes. So what is diameter means? It is also a chord passing through the center. So diameter means chord passing through center of circle. Diameter is a chord passing through center of circle. Okay, diameter is a chord passing through center of circle. And further we can say that it is the longest chord. Diameter is the longest chord. Here clearly we can see the line segments. If you observe these line segments, gradually they are increasing from here, gradually they are increasing, and this is the point where it is the maximum value, and again they keep on decreasing. Suppose we consider that it is a circle with radius 5 centimeter, then diameter is 10 centimeter. So what happens here? It will be like some, suppose 3 centimeter, 5 centimeter, 9 centimeter, 10. Again it keep on decreasing, 9, 7, 4, like this. So even if you want, you can draw it further, 2, 1 and so on. So here when it is the diameter, it is the greatest value, and here this side the value decreases and here this side also it decreases. Now that's why we are saying that diameter is the longest chord. It is longer than all the other chords, right? This is what we have to understand in this. Is it clear? Now how many diameters will be there for a circle? How many diameters? Suppose if we consider this, and how many diameters can we draw means, you see this is one diameter passing through circle, this is one diameter, this is one diameter. So like this we can draw so many diameters for a circle. We can draw as many diameters as possible. You can see that these are all diameters. For they are all line segments. We have to understand that they are all line segments. Okay, like this we can draw as many diameters as possible. We can draw so many diameters. In a now, right, suppose we are given one point in a plane. How many circles can we draw passing through this? Okay, I will take some point like this so that you can is visible to you. How many circles can we draw passing through this point? Can you go for a guess? How many circles can we draw passing through the given point? How many circles can be drawn to a given point of a plane? How many circles can be drawn? Can you guess? How many circles this is, suppose say some point O. How many circles can you draw passing through this point O? Here there is no restriction for us about the radius and all, so we can draw as many circles as possible. The only condition is that circle has to pass through that point. So like this we can draw several circles. Several circles can be drawn passing through a given point of a plane. On the other hand, suppose we are given 2 points in a plane. How many circles can be drawn passing through these two? So for getting this, simply you draw perpendicular, join AB, you get a line segment. Draw perpendicular bisector for AB. Perpendicular bisector. So with A as center and more than half of AB as radius, draw arcs. With B as center and same radius, draw arcs. Okay, you just draw a line passing through these 2 points. Now, by considering this point as center, M is the midpoint and moreover it will be 90. MA is equal to MB. Now, if you consider M as center, MB or MB as radius, you get one circle. Not only this, on this line L, which is a perpendicular bisector, you take any point as center and this distance as radius, if you consider, you get one circle. Okay. Like this we can draw as many circles. Right, just it is the matter of how we are going to draw. Like if you use compass, I think you get these circles in a better manner. But definitely you can draw so many circles passing. Every time you select a point on this edge center, simply you select some point, okay, and then this is your point P, and P compass needle you place at P and PA is your radius, you draw, definitely it passes. What is the logic behind that? You just observe. Now I am going to explain you why. Just we are considering it AB. Okay, we know that this is the midpoint, means these two are equal, and further we know that this is 90. Now if you select any point P on this, I said P as center and PA or PB as radius. Now how do you know that these two are equal? Now observe these two triangles. This is the common side, and now quickly you can observe that for this triangle and this triangle, this is the common side, this is 90, these two sides are equal. So by SAS congruency, these two triangles are congruent. So by CPCT, now you can say that these two are equal. So that's why you take any P on this, the same kind of logic will work out. Suppose if this is P1, this is P2. Again, you can easily prove P2A is equal to P2B. So like this, if you take some P3 like this. So every time this point which is on line L you can take, and with this distance as radius you can draw one circle. It definitely passes through both A and B. What do you mean by drawing a circle? If the circle has to pass through A and B, means there should be a point which is equidistant from A and B. A circle is to be drawn passing through A and B, means you need one point which is equidistant from A and B, and easily we have shown that every point on this line L is equidistant from A and B. So every point on this line is the center and the distance is radius. So here also we can draw so many circles. Now suppose if we extend the same idea for 3 points, what happens? If you consider any 3 points like this, now A, B and C, first join AB, and now I want like I have to draw a circle, means what does it mean? Same kind of logic you apply. The circle which I am drawing, for which I need, for a circle what are needed? Center, radius. Which point is the center and what is the radius? Means I need a point which is equidistant from A, B and C. Suppose if some point P I take, I need it like PA is equal to PB is equal to PC. I need some point P such that it is equidistant from A, B and C. Now for that, what I am doing here is, first I draw perpendicular bisector for AB by using the same principle. This is L. L is perpendicular bisector of AB. Okay. Now also you draw perpendicular bisector for BC. This is like some M. Okay. Now you can see that these two meet at a point, say some P. Now you can see that P is a point on L, means we know that PA is equal to PB. P is on line L, so PA is equal to PB. Likewise, P is on line M, so I can say PB is equal to PC. So what does it mean? From these two I can say PA is equal to PB is equal to PC. So this is our radius. So now you can draw a circle with P as center and PA or PB or PC as radius. You can draw one circle which definitely passes, right? This is the way in which we can draw one and only one circle through 3 non-collinear points. Okay. On the other hand, suppose the 3 points are collinear. What happens? Just let us try to understand this. Collinear means they lie on the same line. Suppose if I take point A and this is point B and this is point C. Now just like the previous one, for AB you draw perpendicular bisector, and for BC also you draw perpendicular bisector. Clearly you can see that these two lines are parallel. So they do not intersect, means there is no point which is equidistant from all the three. Means no circle can be drawn here. When the 3 points are collinear. Okay, this is the basic idea. Okay, just it is only for your understanding. Mainly what are the points that you must know? Now I am going to discuss. The main focus is about tangents and secants. So first let us focus on that. Suppose if we are considering a circle. Okay, and now I am considering a circle and a point in a plane. What are the possibilities? Means the point may lie inside the circle, or the point may lie on the circle, or the point may lie outside the circle. Now if suppose if the point is inside the circle, you try to draw the lines passing through it. Any number of lines you draw, every line will meet the circle at 2 points. Means here no tangent can be drawn. So when point is inside the circle, if it is on the circle, you can see that one tangent can be drawn. And if it is outside the circle, two tangents can be drawn passing through. So here we have to understand that here there are two tangents. Whenever we consider a circle and a point, the possibility is this is center of circle O, and here you can see that point P is inside the circle, here point P is on the circle, and here point P is outside the circle. So here you have PA, PB, two tangents, and here there is only one tangent, and here there are no tangents. So from this we can say that when point lies inside the circle, point lies inside the circle, now you just tell me the situation, what are the number of tangents when the point lies inside the circle. Type your answer in the chat box. When point lies inside the circle, how many tangents are drawn? Type your answer in the chat box. Come on, I'm waiting for your answer. Swati, Kishore, Sampath. When the point is inside the circle, how many tangents are drawn to the circle? It is 0, right? When point lies inside the circle, number of tangents are 0. When point is on the circle, here you can see the point is on the circle. How many tangents can be drawn? Only point on the circle. In this situation, how many tangents? When point is on the circle, it is only one tangent. When point is on the circle, just look at the figure. Here this point is on the circle. Here, like, okay, this is on the circle and you can draw only one tangent at that point. When it lies outside, you can draw two tangents. When it lies outside, two tangents. Okay. Now, here, suppose if we are considering a circle and a tangent is drawn to the circle. This is a tangent. Of course, this is point of contact P and this is center of circle O. Now you join these two. Okay, if you want, you can call it like some A. Now, what is the angle between radius and tangent? This is radius and this is tangent. What is the angle between radius and tangent? Angle between radius and tangent. Can you say? What is the angle between radius and tangent? Angle between radius and tangent. Can you say? What is the angle formed between radius and tangent? You type your answer in the chat box. It is, what will be this angle? 90 degrees. What will be the angle? 90 degrees. Okay. So the angle formed between radius and tangent is always 90 degrees. So this is very, very important. Based on this, you will be given some questions. So first point, you have to remember it. Simply we draw the figure like this. From this, you have to remember this result. We simply draw it like this. This is radius, this is tangent. The angle between them is always 90 degrees. Okay. With this figure, you can remember it very easily. What is the angle? It is 90. This is the first result we have to remember. Now, actually, you see, suppose if you consider any figure, how will they change? I will show you. Suppose here you observe, here I am considering angle and the length of the chord. Red line segment is the length of the chord, and of course we know that BC, blue line, is diameter. BC is blue line segment, it is diameter, and red color line segment is chord. Now you see, okay, I will start somewhere here. Now two things you have to observe. What is the angle and what is the length? So now you observe gradually when the angle is increasing, what is happening to the line segment? Angle is increasing. When angle is increasing, what is happening to the length of the line segment? Can you say? When angle is increasing, what happens to the length of the chord? What can you say about length of chord? So you can see that, just again if you want I will show you again. Just observe, when it is here angle is less and length of line segment is more. Gradually I am increasing the angle. Here you can see angle is increasing. Okay, at 30 degrees, when the angle is 30 degrees, you can see the length is 6.91, and when it is around 50 degree, it is 5 centimeter. Okay, maybe around 61 degree, it is 3.83. So when the angle is, yes, exactly, the length of the chord is decreasing. Means what happens here is, if you keep on increasing it like this, if you keep on increasing it like this, the chord will decrease. Means what does it mean? The secant, the 2 points, if you take it further and further and further, now the angle is increasing. When this point D coincides with B, you can see that you get 90 degrees angle, right? From this we understand that the angle is 90 degrees. When the angle is gradually increasing, the 2 points, what happens? Gradually when it is 90 degrees, right? Okay, now you consider it like this. Now when you are considering the line segments, it is something like 30 degree. Then again if it is increased, it is 50 degree, 70 degree. The distance between the 2 points is increasing. When it is 90 degree, what happens? The 2 points, here you can see there are 2 points and here also 2 points. Now finally this point will coincide with this, and that's so you get a tangent at 90 degree. That's so you can say that the angle formed between diameter, okay, you can say radius or diameter, both are same. Even if you consider it like this, it is diameter. Diameter or radius, the angle formed between them is 90 degrees. This is the first point you have to understand. So what is the first point? Always you can say that whenever you consider a circle, the angle formed between diameter and tangent, the angle formed between these two is always the first result. Okay, so compulsory you have to remember this result. This is very, very important. The first result which you have to understand and you have to remember. Okay, till now just we discussed only the general points. Now this is the first point you have to understand. Now based on this you will be given some construction. How will be the construction? Means you are given a circle. Yeah, okay, suppose you are given some 5 centimeter, 3 centimeter, like that. Now you some P or Q or A, any point is there on the circle. Now you have to draw a tangent to the circle at point P. Draw tangent to the circle at point P. And remember, when the point P is inside the circle, we cannot draw any tangents. Already we discussed this. If point P lies on the circle, only one tangent can be drawn. We know this even. Now the question is, how do we construct this? We already know that the angle between radius and tangent is 90 degrees. Angle between radius and tangent is 90 degree. So based on this we are doing, simply what do we do here is, we join the center of circle to the point where you have to draw the tangent. Now this is radius. Now you want a line which is making an angle of 90 degrees with OP. And this 90 degrees is to be constructed at point P. 90 degrees angle is to be constructed at point P. Now how do you construct? We know that, right, suppose if you consider any line segment, at O you want 90 degrees with O as center and some radius, you draw an arc. With O as center and some radius, draw an arc. With same radius, by keeping this point as center, draw arc. This is 60. Again with this point as center and same radius, draw another arc. This is 120. So we know that this is 60 degree. The angle formed at O means if you consider this point like P, this angle will be 60 degrees. Likewise, if you join these 2 points, the angle formed here will be 120 degrees. Now what to do? You want 90 degrees. So simply draw angular bisector for this. So with this point as center and more than half of this as radius, draw arc. With this point as center and same radius, draw arc. And if you join this to O, you can see that here the angle is 90. So this is one way of doing this. Or another way is simply you produce it further with dotted lines. With this point P as center and some radius, draw an arc. And with this point and more than half of this, you draw arcs on either side. And now simply you join this point to this, then the line which you get is a tangent. This is the way in which you can construct this very easily and quickly. I hope all of you understood this. Okay. The simple principle you have to understand here is you have to draw a line such that, so whenever you want a tangent to a circle at any point, you select the point. Okay, it can be anywhere. Now simply join it to the center, and now you have to construct a line which is making an angle of 90 degrees with OP at point P. Okay, if you can draw any line such that the angle is 90, then definitely that line will become a tangent. Okay, this is the first one. Now based on this this construction, I hope all of you understood this. Now in general the question will be given like, show that tangents drawn from the endpoints of diameter of a circle are parallel. Okay, how do we prove this? Now simply for proving this, what you have to do here is you draw any circle. Okay, this O. Now you draw diameter. We know the diameter means it is the longest chord passing through the center of the circle. Okay, this is O, and AB is diameter because it is passing through center. Now at A and B you draw tangents. Okay, this is PQ and right. This is PQ and this is RS. Now what is given? A circle with center O and AB is diameter of circle. PQ and RS are tangents drawn at points A and B. What is to be proved? What is to be proved? You have to prove PQ is parallel to RS. How do we prove? The proof is very easy. Just you see, in just 2 steps you can prove this. Observe it carefully. We know that this is radius of circle. OA is radius of circle. What is OA? OA is radius of circle. Correct? And PQ is tangent. Already we have seen or discussed earlier that whenever we consider radius and tangent. What is the angle between them? Do you remember? The angle is, what is the angle formed between radius and tangent? Yes, what is the angle formed between? Here once again you see what is given for us. Just observe. We are given AB is diameter of a circle with center O. Given AB is diameter of a circle with center O. PQ and RS are tangents at points A and B respectively. Okay, this is what is given data. And what we have to prove? Simply I have to prove that these two tangents are parallel. That is, I have to prove PQ is parallel to RS. We can prove it very easily. How do we prove? We know that OA is radius and PQ is tangent. And earlier already we discussed this. When we are just simply talking about radius and tangent, what is the angle between them? Can you say? What is the angle between them? Angle between radius and tangent. Got it now? Yes, Monica, you are right. It is 90 degree. Correct. So now simply you can observe that this angle is 90. And what about, again you observe, this is radius and this is tangent. So for this is radius and this is tangent. In the same manner, this is radius and this is tangent. So now what can you say? Again, this angle will be 90. Now you observe, these are two lines, PQ and RS are two lines, and AB is a transversal, such that a pair of co-interior angles are supplementary, because this is 90, this is 90. So 90 plus 90 is 180, means they are supplementary. Co-interior angles are supplementary. So the lines are parallel, therefore you can say PQ is parallel to RS. A very simple proof. It simply depends upon the concept that the angle formed between radius and tangent is 90 degrees. Simply we are applying it above and below. This is radius, this is tangent, angle is 90. This is radius, this is tangent, angle is 90. So 90 plus 90, 180. Means what does it mean? Both are, like you can see that these are two lines and this is a transversal, and co-interior angles, they are supplementary. When co-interior angles are supplementary, lines are parallel. That's how you can say that PQ is parallel to RS. Hence proved. Okay, this is one of the questions which you will observe most frequently. Okay. Now further, if you observe, what type of questions do you observe related to this? Now let us go for it. Now here we have seen when point lies inside the circle, no tangent can be drawn. When point lies on the circle, only one tangent can be drawn, and related to that we have seen two problems. One is how to construct the tangent to the circle at that point, and second one is how to prove that the tangents drawn from the endpoints of diameter are parallel. Now on the other hand, suppose the point lies outside the circle. The point lies outside the circle. Now how many tangents can be drawn for this? Okay, try to construct tangents to the circle from the external point. Now I am going to show you the construction. Just observe the screen carefully. Now what we have to do here is, you will be given the radius and distance with O as center and given distance as radius. Here of course radius is 5 cm given. draw a circle. Then the distance is given 10 centimeters. So with the given distance, locate a point at a distance of 10 centimeters from the center of the circle. Draw line segment OP. Now we have to draw perpendicular bisector for OP. For that, what do we do? With O as center, more than half of OP as radius, draw arcs on either side. Okay. Again, P as center and same radius, we draw arcs so as to meet the previous arcs. So these arcs meet at points say X and Y. Now draw a line passing through X and Y. We can observe that line XY is perpendicular bisector of OP. So perpendicular bisector means the point will become M midpoint. With M as center, MO or MP as radius, draw a circle. It cuts the original circle at points A and B. Okay. Now simply what to do? Join PA and produce. Likewise, join PB and produce. You get two tangents, and here PA and PB are our required tangents. Okay. This is the way in which we can construct tangents to a circle from an external point. I hope all of you understood this procedure. Okay. Just observe here, you can see that the circle cuts the original circle at points A and B. Now draw PA and PB. Okay. PA and PB will become our required tangents. This is the way in which we can construct tangents to a circle from external point. Now related to this, here the thing is, now from P, this external point, we have seen that two tangents can be drawn. We have seen the construction also. This is suppose a point A, point B. Now what can you say about PA and PB? For this, what do we do is join OA, join OB and also join OP. What can we say about PA and PB? What can we say? Right? Now simply what to do? Again you observe, this is radius and this is tangent. What is the angle formed between radius and tangent? Angle formed between radius and tangent. Angle between radius and tangent. What is the angle? It is, yeah, I am waiting for your answer. What is the angle formed between radius and tangent? Already we discussed it several times. This is radius, this is tangent. Radius, tangent. What is the angle? The angle is 90 degree. Okay. So clearly you can see that this angle is 90 degrees. And here also it is 90 because the same logic works out. This is radius, this is tangent. Okay. Now you observe these two triangles. You have two triangles, triangle OAP, triangle OBP. In these two triangles already you have seen that one angle is 90 degree. Here the angle is 90, here the angle is 90. And further we know that radius is same in both. Means what does it mean? This radius and this radius, radius of a circle remains the same. So these two are equal. and further this is the common side for both. It is common in both the triangles. Now right angle hypotenuse side, right angle hypotenuse side, by RHS congruency the two triangles are congruent. What is the congruency rule? RHS congruency rule. So from this now you can say that these two are also equal. Means what can you say? PA is equal to PB. This is the first point. Lengths of tangents from an external point to a circle are equal. Okay, they are equal. This is one result which we have to understand. Now we can talk about one more. Now again I am considering the same figure, right? This is the center of the circle and this is the external point. Now tangents are drawn. A, this B, join OA. Now already we have seen that this angle is 90. This is also, already we know this. Now you observe, what is OAPB? OAPB is a quadrilateral, correct? OAPB is a quadrilateral. Now sum of these two angles, this is 90, this is 90. What is the sum of all the four angles? I take it like some x and this is y. So x plus y plus 90 are okay. You just take it in the same order if you want. X plus 90 plus y plus 90. What is the sum of angles of a quadrilateral? 360 degrees. So x plus y plus 180 is equal to 360. So x plus y is equal to 360 minus 180. So you can observe it is 180 degrees. Sum of these two angles is 180 means what does it mean? X and y are always supplementary. Means what does it mean? You know, if this is 30 degree, or okay, if this is 150 degree, this will become 30. If it is 40 degree, okay, I will write two angles, angle AOB, angle APB. If this is 150, this will become 30. If this is 140, this is 40. If this is 120, this is 60. So every time the sum is 180 degree. Like this, these two angles exist. Which two angles we are talking about? This angle and this. Okay. Just talking about these two angles. These two angles, the sum is always 180. Okay. This is one more important point you have to remember. Okay. Now, right, based on this, what kind of questions will be given means, because we have seen how to draw tangent, first type of questions are, it is given like, from this point, some external point is there, and radius of the circle PA is tangent. Now, this is radius, this is length of tangent, and this is distance between center of circle and radius. Distance. Now already we know that radius and tangent are making 90 degree. So this is a right angle triangle. Triangle OAP is a right angle triangle. So in this right angle triangle, what is the hypotenuse? Can you say? Hypotenuse. Hypotenuse in triangle AOP. What is the hypotenuse in triangle AOP? Come on. You write the name. I'm waiting for your answer. You can type it in the chat box. Swati, Monica, all of you can try. Kishore, Sampath, all of you can try this. What is hypotenuse in triangle AOP? Where is the 90 degrees in that triangle? At which point do you find 90 degrees angle? 90 degrees is at A. So the side opposite to 90 degrees is always hypotenuse. So OP is hypotenuse. Yes, OP is hypotenuse. Okay, very good, correct. Now we know that square of hypotenuse is equal to sum of squares of other two sides. So OP square is equal to OA square plus AP square. This is the result. So the problems will be given based on this. Okay. Now how will they give you the problems means I will show you. The radius of a circle is suppose 6 centimeter and length of tangent, okay, or otherwise a distance between center and external point is 10 centimeter. Find length of tangent. This is the problem. Now first step what to do, you have to draw a suitable figure for this. Here no need to do any construction, just if you draw the figure, rough figure, it is more than enough. Use compass and draw a circle and some point is outside and draw a tangent. Okay, this is, now this is center, this is the external point, this is the point of contact. Now you can see that this is radius. What is the radius given? 6 centimeters. So this is 6 centimeter and distance is given 10 centimeter and you are asked to find this. Now simply we know that this is 90. Okay. Now use this rule. Already we discussed this. Just make use of it. So you can observe that OA square plus AP square is equal to OP square. OA is 6 square plus AP square is equal to OP is 10 square. Right? So what else? 36 plus AP square is 100. So AP square is equal to 100 minus 36 is 64. AP is equal to root 64. Root 64 is 8 centimeter. What is AP? Length of tangent. Therefore, length of tangent equal to 8 centimeter. This is the way in which you can solve the problems related to this. I hope all of you got the way in which we have to solve the problems. Here, this is the principle which we are supposed to use. Okay. Now, Okay, right. I hope all of you understood this. Now clearly you can see that this is the required result. This is very, very important, which you have to remember. Now next one is, already we have shown that whenever tangents are drawn to a circle from external point, they are equal in length. So from external point, if you draw tangents, we know that they are equal in length. That is, we know that PA is equal to PB. This is what you have proved. Now simply we are going to make use of this data for solving the problems. So what type of problems they will give means, okay, you will be given a circle and one quadrilateral is like this. Okay, here of course it has to touch one point. Okay, now this is suppose say A, B, E, and the points they touch are like this is P, Q, it is only at one point, and this is R, this is S. Okay, you will be given only 4 measurements and you will be asked to find the measurements of the other. Now, or you will be asked like show that AB plus CD is equal to AD plus B. How do we prove this? Okay, you can prove it very easily. We know that tangents from external point to a circle are equal. So for this circle, A is the external point. So you can see AS is equal to AP. Likewise, BP is equal to BQ. And likewise from C, you can say CQ is equal to CR. And the same thing you can talk about even these two. That is DR is equal to DS. Now first you start with left hand side, that is AB plus CD. Now what is AB? AB you can write like AP plus PB, and CD can be written as CR plus RD. Now what happens? AP, what is it equal to? AS. So AP I can replace AS. Likewise PB is equal to BQ. Then CR is equal to CQ and RD is equal to DS. Now you rearrange AS plus SD, first and last I am taking, plus PQ plus QC, just rearranging the terms. AS plus SD is AD, BQ plus QC is BC. That's how you can say that it is proved. A very simple result, and this is very important. Even in the exams, like even the same problem is given like this. Okay, it must be like a tangent, it has to touch at only one point, else it has. Okay, fantastic. Now just simply we make of this. Now if you consider them like A, B, C, right, this is given 3 centimeter, this is given 5 centimeter, and this is given 8 centimeter. Then what is the length of BC? So in the MCQ question, there is a scope of asking such type of problems. How are you going to prove this? Simply we know that AB plus CD is equal to AD plus BC. Now AB, sum of these two must be equal to sum of these two. So 3 plus 8 is equal to 5 plus x. This side I take as x. Now x plus 5 is equal to 8 plus 3 is 11. So x is equal to 11 minus 5 is equal to 6 centimeters. Okay. This is the way in which you can solve this problem very easily. Okay. Now let us go for one more problem. Suppose there are two concentric circles. Okay. Now a chord is drawn. A chord is drawn in the outer circle, which is a tangent to the inner circle. You see, chord of outer circle is a tangent to the inner circle. Then how are you going to get the outer radius is given 5 centimeter and inner radius is given 3 centimeter. Now if you observe this, it will be something like okay, just it is a matter of drawing the often, right? Far better than the previous one. Now this is O, this is A, this is B, and this is point P, point of contact. Now AB is a chord in the outer circle and it is touching the inner circle at only one point, so it is a tangent. Now you have to find the length of AB. How do we find? First, to solve this problem, simply join OP and OA. Now you observe OP is radius and AP is tangent. So what is the angle? Already we discussed it several times. So this is 90 degrees. Right? Now further you observe. This is the radius of the inner circle. What is the radius of inner circle? 3 centimeters. So this is 3. And this is radius of outer circle. OA is radius of outer circle, which is 5. Okay. Then what is the length of AP? Now how do you find? First you try to find out by using Pythagoras theorem. This if I take like some x, I can say 3 square plus x square is equal to 5 square. So 9 plus x square is 25. So x square is equal to 25, 4 centimeter. But we want AB. AB is 2 times of AP because a perpendicular from center of circle to a chord bisects the chord. So P is the midpoint of AB. So this is 4 means this is 4 centimeter means this is also 4 centimeter. So you can get 2 into 4, 8 centimeter is the length of chord AB. Okay. This is the way in which we can solve the problems. I hope all of you understood these things, mainly related to circles. What are the key points that we discussed? Just you observe what are the things that you have to understand here. The first one is like when, okay, simply just figures, if you remember, it is enough. This is O, and if you have only one point on the circle, you can draw only one tangent, the first one. And when you join these things, this is radius and the angle formed between radius and tangent is 90, the first one. Next, second one is whenever you consider a circle, tangents drawn from the endpoints are parallel. This is the second one we discussed, the second result. This is O, this is, so L is parallel to M. Next, if you consider any circle, right? Okay, now a tangent is drawn. The external point, this is tangent, radius, this is distance. Now we know that the angle is 90. Then what can you say? B square is equal to R square plus E square. This is the next. From external points, when tangents are drawn, their lengths are equal. That is, PA is equal to PB is one result. And also, if you join this OA and OB, again we know that this is 90 and this is 90. So you can always observe that this is one result, and result number 2 is angle AOB plus angle APB is always 180 degree. Okay, if you remember these results, it is very easy for you people to solve the problems. I hope all of you understood this. We will continue it in our next session. That's all for today. Thank you all. Bye. Okay, thank you students. Now I am going to close the session. Thank you.